All right, good morning everybody, and welcome to another ePrime live stream. My name is Devin Struthers. I'm the Product Service and Support Coordinator for Psychology Software Tools, and today we're going to be talking about our ePrime extensions for fMRI package call. Now, in general, what our ePrime extensions for fMRI package call does is it takes your experiment, or will help you take an experiment and kind of optimize it for running in fMRI conditions. It allows you to add, through a very simple package call method, which I'll demonstrate today, how to set your experiment to wait for a pulse from a scanner, and it also ends up making a special file that we call a PDAT file. This PDAT file is a separate file from the EDAT, or the eData aid file, and this actually just gives you an overview of kind of the runtime and the more fMRI specific types of data, and it allows you to kind of customize what data you see in this extra file. So it's a really useful package call, and we'll just be going over some of the different nuances of it today. Now, what I'm going to be doing first is, instead of just opening up a blank experiment, since we have a lot to talk about and there's a lot of nuance with this package call in particular, instead of opening up a blank experiment and showing you how to build it, I'm actually going to open up one of the tutorial experiments for EE-fMRI, and I'm going to use that as my starting point. So what I'm going to do is just go into my samples on my computer under my experiments, and if you download ePrime extensions for fMRI, you're going to have this little folder here called fMRI, and it's going to include a bunch of samples and a tutorial. So the tutorial today is just going to be walking through this fMRI press experiment file, and if you see here, there's a lot of versions of this file. These are just incrementing it slowly. So we'll start with press, and then we'll turn it into fMRI press, and slowly start adding those EE-fMRI components to what we have here already. And the end result is going to look a lot like this fMRI press sample that we have right here. Now, as you can see here, we have our version of fMRI press. We also have a Celeritis version as well. Celeritis is our button response unit. It's all fiber optic, so it's meant to go inside of a scanner bore. And if anyone has any questions about that, I'd be happy to talk about that. Otherwise, I would like to direct you just to our product page. If you just go to just our site here, just go to pstnet.com. Just go to products, hardware, and then response devices, and then Celeritis fiber optic button response system. This is really what our response system is for fMRI devices, or for any fMRI situation. And we do optimize our experiments in here to work with Celeritis as well. So we're going to be just focusing on the normal one, which will be primarily keyboard press, but just know that changing it to Celeritis is very easy as well. This also includes something called Mapper1. What Mapper1 is a sample is just a brief battery of tasks to run through. Just something that, it's a very basic fMRI type experiment with all the package calls and all of the timing enabled on it as well. So today what we're going to do is we're actually going to just start with this press.es2, and I'm just going to open it up here. And instead of spending the time building it, because there are quite a few things to build in it, especially if you watch some of our other live streams. Building these things is very simple. Adding an instructions object, adding a stimulus fixation feedback, and even a rest object, it's very simple for ePrime to handle. If you would like to learn more about adding these objects or changing some of the very nuanced properties that are already set in this experiment, I do recommend taking a look minimally at our ePrime 2 live stream, or ePrime 3 basic webinar live stream. That one's just on our YouTube channel, so give that a look. Otherwise, just going to walk through the experiment very quickly. What it is just I have an instruction screen at the beginning. It says, in this task, you'll be asked to press a button using a specified finger. For example, right pinky requests that you press the button lying under your right pinky finger. Press the assigned button as quickly as possible. And if we take a look at the duration input of this, it's set to infinite, and it's waiting for a keyboard response of enter. Now, of course, the task is kind of written like you're in an fMRI environment. So it's written in such a way that, they already have a button or a hand unit underneath, their hand, and they just press any button on there. This is keyboard enabled just because we do have a keyboard and mouse setup here today. So after instructions, I have a block list, and my block list is actually set into three different possible conditions. I have a rest condition, a press condition, and then another rest condition, and this experiment is just meant to go through these in sequential order. So participants are told, hey, welcome to the experiment. Then they go to this rest object, because if you see here, ePrime is first going to hit this rest block proc. So we'll go to rest, and this is just a basic fixation that stays on the screen for about 20,000 milliseconds. Now, there's one thing that I want to point out here is this timing mode. And if we take a look at a lot of our objects here, you're going to notice that timing mode property, and I know I'm opening these kind of quickly, but the point is to highlight these timing mode properties. Now, if you'll notice, this isn't ePrime's standard timing mode. And this is something I really do want to point out because it is important for fMRI studies. The timing mode property here is set to cumulative. Now, ePrime's default timing mode is event. Now, what event means is event is actually going to just tack on time to the end of a trial if you have any delays in any of the objects appearing. The delays in the objects appearing is what we in ePrime call onset delay. So if there's any onset delay, so if ePrime, or this stimulus object, for example, if this object takes, let's say, an extra 10 milliseconds to appear, ePrime is actually going to lengthen the trial by 10 milliseconds if you have the timing mode set to event, which is ePrime's default. Now, this ends up being problematic for fMRI experiments because you end up wanting these trials to line up with the pulses in your scanner. If you have the timing mode set to event and ePrime just starts tacking time onto your trials, you're going to end up having your trials and your pulses not line up correctly, and that's less than ideal. So what cumulative timing mode does is it actually makes sure that the timing of the entire trial, so in this case, stimulus, fixation, and feedback together is what I count as one trial, it makes sure that the timing of the trial is as stable as possible and is always going to be the same amount of milliseconds no matter how many times you run it, regardless of onset delays. Now, there are still going to be onset delays in your experiment, but what's going to happen is ePrime's actually going to artificially shorten any object to account for that onset delay. So, in this case, the duration of my stimulus object is 1800 milliseconds. Let's say I have and this is a bit extreme, but let's say I have a 100 millisecond onset delay for my stimulus object. Again, that's a very extreme example. You won't ever have anything that extreme, but let's say that we do. Let's say that stimulus has a 100 millisecond onset delay. Under cumulative timing mode, what ePrime's actually going to do is it's going to shorten the duration from 1800 milliseconds to 1700 milliseconds, or 1700 milliseconds. So this will be on the screen for 100 milliseconds less, but it's going to ensure that the timing of the entire trial is consistent. So for fMRI experiments, it is important to keep this timing mode set to cumulative. And if you run the attached sample or run through the documentation that comes with fMRI, there's actually a whole section on cumulative timing mode and why that's better for you in fMRI environments. So I definitely recommend checking that out because it's really great information if you want to get your timing down really good for fMRI samples. All right, so we have that rest object I talked about. So then after we run our rest procedure here, the next thing we have is our press procedure. So this is going to be actually the series of trials that we're going to run. And you see here we actually have 10 different trials that we're going to run, and ePrime's going to randomly select from any one of these objects or any one of these trials. And all it does is it changes which hand the participant is using to press, and then it just cycles through the buttons. So are we responding with our right hand or our left hand? And then are we using the thumb, index, middle, ring, or pinky finger to make that response? And then in the right column here, this correct answer is the corresponding correct answer on the button response unit. So for example, the right thumb, which is just the right thumb on the hand unit, would be denoted as 1 in ePrime. The right index finger is 2, middle finger's 3, ring finger's 4, pinky's 5, and thumb is 6. And then with the left hand, it just kind of keeps going from 7, and then instead of 10, it's actually an A. So that's just how our Celeritis unit logs these, and that's why they're logged in this way. Obviously, you can't really set your fingers up to have your ring finger on your left hand on the 9 key and then your left pinky on A, unless you have really gigantic fingers, in which case it's impressive. But this is made primarily just for our for that Celeritis device. So that's why those are set up that way. So our stimulus object is just showing a mixture of hand and finger. So it's going to show you the right hand or left hand and then tell you what finger to respond with. Our correct answer attribute is being referenced under this correct property right here. Timing mode is cumulative. The duration is 1800 milliseconds. Data logging is set to standard, pre-release set to same as duration to ensure enough time to load the fixation object afterwards. But one of the important things to keep in mind as well is this end action property. Now this end action property here is set to none. So what's going to happen is the participant's going to press a button on the hand unit that corresponds with hand and finger here. E prime's going to check it for accuracy. Then once the participant responds, it's actually going to terminate the input mask, but it's not going to terminate the stimulus slide object at all. Since end action here is set to none, E prime's just going to stay on this slide regardless of whether or not a participant made a response to this for the entirety of the 1800 milliseconds, or a shortened version of it if there's any onset delay. But it's going to stay on this for the entirety of its duration, and then it's going to move on. Again, this is just to ensure that our trials are exactly the same length and responding doesn't artificially shorten the trials. So then after the stimulus object, participants are going to see a fixation. And then after the fixation object, they're going to go ahead and see this feedback here. And then the feedback just corresponds to, did they press the correct button on the response device? And responding specifically to that stimulus object. Now what I'm going to do is I'm actually going to take this experiment, I'm going to modify it to add our fMRI package calls. So what I'm going to do first is I'm going to double click on this experiment object at the top of my structure window, and I'm going to take my mouse and navigate over to packages. Now packages are where you can load different packages or pre-written bits of script into E prime. And if I click add, you're going to see that we already have the fMRI package installed on our system. So if I select the fMRI package and click OK, it's going to tell me first what version I'm running. This is the latest version that's compatible with E prime 2.0 Service Pack 2, or build number 2.0.10.356. And then it's going to show me the location of the package file, and I just have it saved in my local folder there. So I'm going to click apply and OK. Now the first thing I want to do is I want to tell fMRI, or E prime, that this is the beginning of my session in the scanner. Now to do that, what I would do is double click on my session proc, and I would grab this thing called a package call object. Now we haven't worked too heavily with package call objects in the past, but we're going to be working with them pretty heavily today. So I'm going to take them and I'm going to drag this package call object just before my instructions. Now the point of a package call object is that I'm importing pre-written bits of script into my experiment to be called whenever I want. And in order to interact with a package call object, go ahead and double click on it, and first you have to select the package that you want to load. Now, I only have one package in my experiment, it's fMRI, so it only makes sense to click on fMRI and add this one. But if you have an instance where you're having, or you might have maybe a NetStation set up with an eye tracker, or you're using fMRI with some NetStation stuff, you might have multiple package calls here. But in our case, it's only fMRI, so package is only ever going to be set to fMRI. Now, once you have your package set, E prime knows that it's looking at the fMRI suite of possible bits of script. Those bits of script in E prime are called routines, and in the actual package call itself, they're all set up as subroutines. So if you click on this drop down here for routine, these are all of the routines that you have in this script, or it's best to think of it as these are all of the functions that fMRI can perform. Now the first one we're going to do is just session init. So what session init does, and it gives a little overview here, is it just initializes the fMRI support on the session level, and it opens that PDAT file and writes out all of our default column headers. So we have different properties here that you can change. So first, there's a string state. You can turn it on or off. Mainly keep this off if you're just doing testing. Keep it on if you would like to make that PDAT file at the end. You can change the PDAT file name if you would like. Right now, it defaults to the same as your EDAT file. But if you want to name it something in particular, so if I wanted to name it, for example, Devin is awesome, I can do that, and then that's going to be the name of my PDAT file. But I would like it to remain the same as my EDAT, so I'm just going to keep it at its default there. And then if you have any specific columns that you would like to add to this PDAT file, so if there's any specific data that you want to log or anything similar to that, you can actually add it here as an optional parameter, and then you just denote them by using this backslash. So user1 backslash user2. In this case, they are adding 5 user variables or 5 user-defined variables or columns in that PDAT file. So that's really all I need to do, but once I clicked apply, I got this error message here. It says the routine selected is not a substring of the name of the package call object. This is not an error, but you're encouraged to name the package call to reflect the routine chosen. So what this is telling me is my name of my package call object is called package call 1, but it is an fMRI session init type of package call because that's the routine that I'm calling. ePrime recommends, and like I say in all of my webinars, the name should reflect the function, and the same is true for the package call object. Now, if I just go ahead and accept all of that, package call 1 doesn't tell me really anything about what this package calls do. So what I want to do is I want to rename this from package call 1, and I'm just going to call this fMRI session init. And now if I open this up and click apply or click OK, it's not going to give me this error message because what ePrime does is it just compares the routine to what's on the name, and it's looking for the word session init in its name. And that's all it's doing. It's not an error message, but it's just saying, hey, you should probably follow some of our best practices as far as naming conventions are concerned. So now that we have our fMRI session init package call added to our experiment, we're now creating a PDAT file. Like, that's what we're doing, and that's how ePrime knows, hey, this is what we're going to be doing here. So now we need to actually tell ePrime that the run has also ended. So we're going to say, or we're going to tell ePrime, hey, at this point, this is when we need to kind of stop our running of the experiment. This is when the PDAT file needs to close out. So what I'm going to do is I'm going to add another package call object, and I'm actually going to put it just before the goodbye object. No, I'm going to put it just after the goodbye object. And I'm going to rename this one to fMRI run end. Now, I'm kind of jumping a little bit ahead with that name because I already know the routine that I'm going to be adding. But if I go ahead and look here, I'm going to add fMRI as my package call, and I'm actually going to add the routine called run end. Right here it says designates the end of a current run by writing run end into the PDAT file. An optional timing report will also be generated and displayed to the user. So this actually closes out of the PDAT file, and then it gives something called a run report. And I actually have a pretty good image of that run report here that I'd like to show you guys, just so you get a good sense of what kind of stuff this package call is already adding just by dragging and dropping it to the experiment. So I have this just on my desktop here. And this is the run report. So if I go ahead and open this up, what it does is it tells you the run, it gives you the title of the run if you've given it, it tells you the status of it, so was this an okay run, was there anything wrong, were there responses to this, and then if there were responses, what were their accuracy, their mean, and what was the correct RT of the mean. These are really important, especially if you're going to be logging some accuracy and stuff like that. We'll be adding these into the experiment later, but right now this was just kind of from like a blank and very basic run. Now the important parts here are going to be that start time and end time. Now the start time is actually just going to be, it's going to be basically just the time at which the trigger from your scanner, or a simulated trigger if you so choose, comes into ePrime. So basically this is when ePrime says, this is when I received the first pulse, and I said, okay, we're going to start running the experiment. And I'll show you how to set it up to wait for that pulse as well. But this end time is then saying, okay, this was the end of the experiment, this is when I ran into this fMRI run end, and then it lets you know how long your run was in minutes and seconds, and then milliseconds afterwards, obviously. So by just dragging and dropping that end run package call right there, that run end package call, you end up automatically getting that report at the end as well, which is really helpful. Now, like I said, you do have an option in the parameter to turn that off if you would like, and all you would do is, where is it, right here, report duration. You can actually just set it to 0 and it'll disable the report. And right now it's set to -1, and what -1 means, which is the default value, it just means that I'm going to leave this report displayed until I press the enter key. So it'll be a nice kind of way to end the session, just to be like, okay, this was my data for it, and it's a very high level view of the data that you've collected in the experiment. So now that I've opened and closed my PDAT file, and I've even made that run report at the end, what I want to do is I want to explicitly tell ePrime, hey, this is the start of my session, and I want ePrime to basically hang on a screen until I receive that trigger from my scanner. So what I'm going to do is I'm actually going to add another package call object between the instructions and the block list, and I'm just going to call this one fMRI run begin. So the difference between the session init and the run begin, because they do kind of seem the same, is the session init is what opens the PDAT file. the run begin doesn't open the PDAT file and write any of the default columns. This is what hangs and waits for the trigger to come in from your scanner. So I'm going to add my package as fMRI, and my routine is just going to be run begin. So what it does is it actually designates the beginning of a new run by writing run begin in the PDAT file. And we needed that session in order to make the PDAT file for this to write to. By default, the command will overlay a text message on the current screen and then wait for a designated trigger to start the run. So right now, if we look at our optional parameters here, we have this trigger time. Well, trigger time is just a millisecond timestamp associated with trigger, like it says here. What it's going to do, if I call -1 here, it's actually just going to hang on this object until a response is made. And then here I have a conditional string ID. What this does is a string that identifies the current run condition. So if this is like a practice trial, for example, I can write practice here. But this is just only going to be one run, so I'm going to keep that as a blank string. The next one is a trigger key. Now this is actually going to change depending on your setup, and this is what is E prime looking for by default as the pulse from your scanner. And different devices set this up differently, but how we have it set up right now are the equal key, the upwards caret, enter, and escape. Now if you're using a Celeritas device, this upwards caret is going to be the important one for you because that's how E prime logs, or the Celeritas device, logs the pulse from the scanner. But if you're using different response devices or a different method from getting the pulse from the scanner to E prime, this key might change for you. So this is something that's important to know, not only about E prime and how it's set up, but it's also important to know about your scanning environment as well. So we have a lot of flexibility here as far as making E prime wait. And if you notice here that it has a trigger message, there's a trigger message that just, it allows you to define what it says on the screen. And the default trigger message, I'm going to show you here because I have another image of it. It just says wait for trigger. So there's our instruction screen, but if you look overlaid at the very bottom here, it says waiting for trigger. Press enter to start manually, escape to cancel, control alt backspace to break. Otherwise, it's waiting for that upwards caret trigger that Celeritas is going to send to it. So that's just what is going to show on the screen, and that's what that package call adds to the experiment as well, without even having to make any of that or write out any of that logic in the script. Because, I mean, scripting it wouldn't be too terribly difficult, but this just saves you a couple steps. So along with making this PDAT file and waiting for trigger, we actually have another kind of functionality that this adds to that EEFMRI adds to E prime, and that's the ability to make a menu in E prime. Now what this menu does in EEFMRI is it's actually going to take a look at a list that you point it to. In this case, it's going to be my block list, and it's going to turn it into a selectable menu. Now on this particular task, what it's going to do is it'll allow me to choose between my rest condition and my press condition. And I understand that might not be the most dynamic kind of list object, or might not be the most dynamic kind of menu based on a list object. But what it does do is if you have a battery of tasks for participants to run, and they can run those tasks in any order that they want, this will allow them to select one of the tasks to do. And a good example of that is if you go into our samples here, and I'm just going to open this up quickly just to show you. If you go into this MAPR1 sample, a very effective use of this menu device is implemented into this because it allows you to select the battery of tasks that you're going to be running. So if you go into this run list, you can see that we have a couple of tasks. We have a visual motor task, a verb generation task, an NBAC task, and some novel pictures. And this is already packaged with E prime. This is something that you're with E prime extensions for fMRI. So if you purchase it, you already get this task. And one of the big selling points too is this NBAC task, because making an NBAC in E prime is kind of difficult, and this one already makes it for you. But when you run this experiment, what happens is participants are shown just a list or a menu of these tasks, and then they can select which one they would like to implement or which one they would like to run themselves. So that's kind of the best implementation of that menu that we have in E prime extensions for fMRI. And to add that, it's literally just as easy as adding the run begin and run end and session init. So we're going to take a package call object and we're going to put it just after run begin. And this one's just going to be called menu begin. So we have fMRI, menu begin. And I'm going to double click on this. I'm going to change my package to fMRI, and I'm going to change my my routine here just to menu begin. Now, if you take a look at some of the parameters here, what it says is the first one is menu state. So this allows you to either disable or enable the menu. In this case, it's on because I would like it to actually work. Now, I am going to have to change one of the parameters though, because the second one is called the menu list. This is the list object that will be used to create the menu. The list object is required to contain an attribute whose contents defines the text that will be used in items that are displayed by the user. The default attribute is expected to be named menu item, but you may change the menu item to whatever parameter you'd like. So in this case, instead of run list, I have all of my items that I want in my menu in my block list. So I'm just going to change this to block list. Now it says it's looking for something called menu item, which is going to end up being the text of the menu or the textual selection, and it's going to look a lot like this at runtime. So right now I have one, and my one item in my menu is just called press. But I'm going to be adding a few. I'm going to add a press, and I'm going to add a release, and I'm going to add a second, or press and a rest, and I'm going to add a second rest. So right now it's looking for a column in my list object called menu item, and right now that doesn't exist. So I'm going to hop into my block list here. I'm going to add an attribute. I'm going to call this menu item, just to be in line with the package call object. Whoops. Windows wants me to update, and I'm going to tell it no. So I'm going to make this menu item here, and what this is going to do is just be the text that's shown. So I'm going to call item 1 first rest. That way, the selection that they have on the menu says first rest, and it'll jump into this procedure. Then my press is just going to be called press, and my second rest one is going to be called second rest. So now I'm going to have 3 menu items whenever this appears. I'm going to have first rest, press, and second rest. That's going to be completely fine, and that's exactly what I want. So I'm actually just going to hop back into my menu begin here just to make sure that it's everything that I want. So I have my menu list. Now I have my menu item attribute. Now my default is that menu item attribute that I had just made, but I can name this whatever I want. Again, if I want to call it like super awesome list or something like that, I can do that, but I'm going to keep it at menu item for now, and then this handle pre-release isn't something I really need to touch. So that's all I need to do here to make that menu. So the only other thing I need to do now that I've made my menu is I need to do 2 more things in order to get this menu to function properly. The first one I need to do is I need to actually add a menu end. That way ePrime knows, okay, there's no more menu, like they're going to be done selecting from this, and I'm going to put that just between my block list and my goodbye. So all I do to make that is I take a package call object and I put it just between my block list and my goodbye. This just kind of denotes where the menu is going to be ending in ePrime, and since if you look at my procedure here, my menu is located on the block list, it makes sense that the beginning of my menu is before the block list and the end of my menu is after the block list. So I'm going to go ahead and rename this one to fMRI menu end. And again, my package for this package call object is fMRI, and my routine is going to be menu end. And if you notice, there really aren't any parameters here for me to set like there was in my menu begin. I don't have a list object I'm pointing it at because ePrime already knows, hey, there's my menu up here. It's just ending whatever menu is currently in existence. Right now, it's just a nice thing to do to kind of clean up the task at the end of it. But this is also more important if you have kind of a really long task and you want stuff to happen after the menu. So you want, let's say maybe if you're using this, this mapper one, let's say you want, after this, you want a series of questions after they've run all of these tasks. If you want that to happen, then you would put the menu end just before all the questions that you have. So I only need one more package call in order to make my menu function correctly, and it's going to be the reset list by name package call. Now what that does is it actually allows you to reset the list. So let's say I selected first rest, for example. ePrime's going to run it, and it's going to say, okay, I've run this already. It's going to essentially turn this weight to 0, and it won't let you select it anymore. But if you want participants to be able to kind of work through these however they want, it's important to reset the list to make sure that participants can actually select items on the list. And that's exactly what this package call does, is it kind of resets the list so all of the items on it are selectable. So I'm going to take a package call object and drop it just after fMRI menu begin. And I'm going to rename this one just to fMRI reset list by name. And again, I'm cheating because I know what these package calls are called, but you can always rename them afterwards if you'd like. But I'm going to change my package to fMRI, and I am going to change my routine just to reset list by name. And if you see here, it says accepts a common delimited string of list names and performs a list.reset call to each of the ones that are named. So if you look here, I don't actually have a list reset. So all I need to do is just type in the name of the list that I want to be reset, and in this case, it's going to be block list. And hit enter, and then apply and OK. Oh, and so it actually got that warning message, and the reason is because it's called reset lists by names, so multiple, and not just reset list by name. So I'm actually going to go ahead and rename this one to reset lists by name. And now if I click OK, I don't get that warning message anymore. So that's really all I need to do in order to reset my block list. So I'm going to go ahead and click OK. So now what I've created is my session, my run. So this here is going to wait for a trigger or for me to press enter. And then now I have my menu already set up, and my menu is going to reset my block list every time it runs. So I'm going to go ahead and save this right now, because I want to run it to test it out so far, because right now it's sounding pretty cool. I'll just call it press webinar. And I'm going to go ahead and click run, and we'll see what happens. So this is important here. It says fMRI reset list by name type mismatch in parameter 2. And this is how you would kind of troubleshoot some of these things. So I'm going to go ahead and show that error message one more time just to get that on screen. So the error message is happening in my fMRI reset lists by name package call. And it's telling me there's a type mismatch in parameter 2. So let's go ahead and take a look here. So it says fMRI reset list by name is where it's happening, and the type mismatch is happening in parameter 2. Now if you look, I only have 3 parameters that I could possibly choose from. My first one is context, and that one's fine. The next one is this string list names as a string. Now if you notice, this isn't actually a string. This is just the word block list. In order to get this into a string, all I need to do is put quotation marks around it there. So now there shouldn't be a type mismatch because it's a string because I put the quotations around it. So go ahead and click OK, and I'm going to run it one more time. We'll see what happens. So now I've moved on past that. I'm going to enter subject as 0 though. So that's the other thing that I do want to bring up about EEPRIME extensions for fMRI, and that's one of the main reasons why I wanted to do this run, is unlike some of our other products that need a key for design time, EEPRIME extensions for fMRI actually comes with that hardware key. It's another little green hardware key, but this is actually essential for runtime of the experiment, not necessarily design time. So for those of you who have a single user license of EEPRIME 2, if you have that little green hardware key, you know that you need to plug it in order to access eStudio, but you don't need the hardware key for eRun or for subject stations. The exact opposite is true for EEFMRI. You get that little green hardware key, and as you saw, I can start making experiments in eStudio without that hardware key plugged in at all. Where the hardware key kind of grace period message comes from is whenever you hit run, you're going to get this one. It just says no hardware key detected. Please connect the hardware key that came with and try again. So I'm going to click OK, and it actually kind of exits me out of the experiment. And then that validation error 4 is just, hey, I don't have a hardware key attached. So that's one of the things that's important to keep in mind when you're running this is, you know, do I need that hardware key, and then is it attached at runtime, not necessarily at design time. All right, so now that I have all of my lists set up, I want to actually start building up what my PDAT file says. So my PDAT file right now, if you look at my session init here, it's just going to add the very basics of my file here, or very basics of my PDAT file, and that includes onset time. So what time was the sample taken? Target onset time. What time was it supposed to run? Runtime. So how long did it run for? Record ID, which is something you can set during runtime if you want. Then it sets duration of the entire experiment. It sets something called condition ID, which is something that you can set in the experiment as well. Condition level, which is a log level that's assigned to the hierarchy of the experiment. And then it logs more specific object-related things. So it logs response, correct response, accuracy, response time, those kinds of things. And there's actually a really great chart, and I'm going to pull that one up very quickly. There's a really great chart if you go to our, if you go to the documentation for this. So, and this should be located just on your C drive here. So if I go to like this PC, go to the local disk, go to Program Files, PST, and then EEPROM extensions for fMRI and documentation. So this is just our user manual. I'm just going to open it up with just, you know, basic. In this case, it's just going to be Microsoft Edge. But in Appendix 2, we actually have a really great chart. And I'm going to just show you that very quickly. At the very end, and it just shows you what is already automatically logged. Oh, it's Appendix F. Right here. This is automatically logged in the PDAT file. So this is all the chart that I just went over. So the onset time, the target onset time, the run time, the record ID, the duration, condition ID, condition level, and then these are all of the object-specific things, and we're going to start to log those for our stimulus object in a second. And then this is that user one. This is a user-defined column, and those user-defined columns, as I mentioned before, are set in this session init here. So it says this is where you can actually put those user-defined columns and start adding more and more and more of those. But for now, I'm just going to keep that one, or keep that as is. I'm not going to do any user-defined columns. But since we're already making this PDAT file, I want to actually start associating this response, correct response, accuracy, RT, and RT time, as well as give it some events for it to start logging properties of, or start logging time limits for. So the first one I want to log data about, or data for, is this REST block proc, and specifically this REST object. Because there's really two conditions that I'm going to be focused on in this experiment, the REST and then how they respond to stimulus. So the REST is just going to have something called log event in it. And what this does is it just writes data to that PDAT file in relation to whatever event that I tell it to. So I'm going to take a package call object, and I'm going to drop it just after my REST object. And I'm just going to rename this one to fMRI log user event. There we go, block. Because in essence, this REST object is my entire block, and this is just going to be logging for that block. So I'm going to take a package call and make that fMRI, and then this is just log user event. Now, I want to take a look at some of my parameters here, because if you look, there's a lot of parameters that are automatically added here. And the first one, obviously, is C, the context. We're just going to leave that one alone. Generally speaking, you don't ever need to change this C in any package call object. And the first one is onset time. So this is the onset time that will be associated with the event. If you set this to a -2, which is the default, it's going to get the target, or it's going to get the timestamp by calling get next target onset time. If you set this to -1, it's going to get the timestamp by just calling clock.read. I'm going to set this to -2 just because it's actually going to figure out that get next target onset time, and that's going to be a little more precise for us. And then the next one is the target onset time, and it's going to be exactly the same. Instead of doing the clock.read, which would be denoted with -1, I'm going to keep this at -2, which is actually just going to get the next target onset time. The next one is a record ID, and if you took a look at that chart, that might be, or that's one of the columns. This is just a string that describes a type of event that's being recorded, and the default is just generically the word event. But we want to make this specific to our experiment because this is the REST, not just a generic event. So I'm going to change the name of this just to REST. And like with that block list, this also needs to be in quotation marks to make sure that everybody, or make sure that EEPROM knows it's a string. Otherwise, I get that exact same error message. The next property here, this -2, is, or next parameter, sorry, is the duration. So it's the duration that's associated with this event. If I set it to -2, it's going to flag the value to be calculated via post-processing, which means that it's going to tell me how long this was on the screen after it's already run. So it's just it'll actually programmatically tell me how long this was on screen, and it'll be an actual representation of the duration. We recommend -2 because -1 is just reserved for future use. And then there's condition ID, which is, again, another column in that PDAT file. If you go here, this is that condition ID. So record ID was that first one. Condition ID is that second one. And it uniquely identifies the condition here. And in this case, I'm going to keep it blank because all I really need to do is in my PDAT file, just make sure I know that this is a REST object. And then after my conditional string ID, I can actually put some user-defined data here. If I have any of those user 1, user 2, user 3 columns, this is where I would specify what goes in that column. But I don't have any of those, so I don't need to change any of that. I'm going to go ahead and click Apply and OK. So that's how I would set up some data logging for my REST object. Now I need to set up some data logging for my stimulus object, because that's the one that's going to be really important to me. And it's going to look just a little different. It's going to be event stimulus. It's actually just going to be called response event. So what I'm going to do is, in my trial procedure here, I'm actually just going to make this one the last object in my procedure. I'm going to take this package call object and put it just after my feedback object. And I'm going to rename this to fMRI log response event. I'm going to make the package fMRI, and the routine is of course going to be response event. Whoops, log response event. There we go. And again, this has parameters as well that I need to work through. So the first one is C. Again, don't need to change that. The next one is the object. So what object am I collecting data about? And this is just generically object collecting responses. It's a placeholder. It's just meant to say, hey, this is where you put the name of the object that you're collecting responses to. And in this case, the object that I care about is called stimulus. So I want to delete what's here and just type the word stimulus. This one doesn't necessarily need to be in quotes, and you know that because this parameter here doesn't say string. It says RTE runnable input object, which is just going to be the name stimulus because stimulus is a text display object. The next one is the duration. I have two options, -1 or -2. -1 is set the duration of the value to the object's RT property, which is what I'm going to want because that's going to fill in that RT column in my PDAT file. So right here, it'll fill that one in with the RT value of the stimulus object. Or I could set it to -2 and it'll just be calculated via post-processing, but I would actually like the RT property better here anyway. And then this is a conditional string ID, so if there's an experiment condition related to the event. So if this was maybe my practice set of trials, I could say something like practice. And then for my critical trials, I would actually change it to critical. But in this case, it's just going to be my press trial, so I'm just going to call it press condition. And then I have an option here to put in user-defined data. So again, that user 1, user 2, user 3, I have the option to define those here as well if I so choose. But I don't, so I'm going to click Apply and OK. So that's how I would log response-related events. Now, I only want to add one more package call to this experiment, and that's going to be just after stimulus, because I would like data just to be in my experiment about stimulus object and just about how long it's been on the screen. I'd like the same type of data that I used for my REST object, but I want to use it for my stimulus object. So I'm just going to add one more package call here, and that package call is just going to be fMRI log event stimulus. So I'm going to rename this to fMRI log event, and then it's just going to be stimulus. So I'm going to double click on this. I'm going to add an fMRI as my package, and my routine is just log event. So what this does is it logs my event recorded to the PDAT file. It's recommended that you place this after the object that you associate with the event has been run. So in this case, I wanted to log information about stimulus, so I put it after my stimulus object. Now if I work through the parameters again, the one that I need to change here is my object. Again, it's just object presenting stimulus, which is, again, just a placeholder. So I'm just going to rename this one to stimulus. My duration is set to -1. It's going to be the exact same as my fMRI log responses one, so I'm going to keep that as -1. And my string condition ID is the condition, so this is just going to be press condition. And I don't have any user-defined data. So then that's all I really need to set up my experiment. And that's all I actually need to set up my experiment to be compatible with our EEFMRI package calls. So now if I look at my experiment, it's actually set up to run in an fMRI environment in the most efficient manner. I have this fMRI run begin. E' is actually going to pause on this screen and wait for a trigger to come in, and it'll even display text on the screen to wait for that trigger to kind of sync your experiment with the pulses of the scanner. I'm going to have a menu appear that's going to allow participants to select programmatically what they're going to be running. And then I have all of this data that's now being written to my PDAT file. I have my fMRI user log event block, I have my fMRI log event stimulus, and my log event response, or my log response event. So now all of the data that I'm going to be collecting not only is going to be written to my EDAT file, but it'll also be written to that supplemental PDAT file as well. That way I have a whole text file, or what we call PDAT file, that has all of this really relevant information to my scan. And at the end, I'm even going to display participants with, or researchers in particular, I'm going to show them this run report at the end, and it's going to tell me more information about my run right away, just so I have a clear indication of where my data is going right when the run's finished. So that's all the material I have for our webinar today, or for our live stream today. If you guys have any more questions at all about fMRI package calls or making your experiments fMRI compatible, please feel free to go to support.pstnet.com. We are more than happy to answer any questions you might have. If you have ideas for future live streams, please feel free to shoot us an email or maybe respond on this video in the comments. I'm also happy to take any recommendations as well. Don't forget to like and subscribe to our channel. It allows us to keep doing what we do here and make these, make all these helpful tutorials for you guys. And yeah, if you guys have any questions, please feel free to go to our support site. Otherwise, thank you guys so much for coming today. Hope you had a great time.